Okay. I think we can slowly start. I think just a quick reminder that for our class that we would be having the B.A. lab for the until the to get a B.A. lab for the next class, for the next 3 classes. So we try to get the rest for the B.A. class as well, but we will let you know if we're successful. So the goal today is try to finish the whole thing, but I mean, of course, we try to be ambitious, but if not, then I will cut something like time series model or some logic model, but otherwise, I will keep the main thing is there, but just cut some advanced topic, but we still keep the machine learning, don't worry. I mean, the main thing I will still be there, but there's some thing I will cut, but I already know what I'm cutting, but so far, the first 5 to 6 chapter, we still keep them because they are the foundation of what we're doing. Well, I mean, there's something we'll cut. So the go back to things that we do in last month, right? So we stopped somewhere in the standard deviation, if I remember correctly. If I correct me wrong, I mean, I think we just stopped somewhere in the middle here, right? Am I correct, right? Right? Or we just cover this guy. So just to remind you the lesson 3, what we are doing, right, is to look at the hypothesis testing and the some estimation technique that we'll be working on. Okay. So let's quickly go back to this problem of example of looking at stock price, right? Probably you would know this is the price data from S&P 500, and then the question that was being asked is to calculate the probability that more than 5% loss, right? If you assume, make some assumption like the price follow normal distribution, 服从那个正态分布, then it's easy, right? You can calculate immediately, or whatever distribution you have, you make the assumption, then you're done, right? But the problem is we want to test from data, right? So how does that work, right? So that would be things we want to look at, okay? And I think that's what we did is last time is we look at this S&P 500 data, right? This is how we done. No, maybe I should open the code lab that allow me to look back the code that we have studied. Just I should have logged in earlier, but I'm sorry about that. Sorry for they have the 2-step checking, and then so I think our class is class IT or IS? IT, yes, IT class. Wait a bit until I load the code here. Okay. So I think the last time we just stopped somewhere at the bottom, right? We run the return data, right? Just basically we just stop at the rate of return, right? So we start the price data, right? This is how we download data. And then we start to clean the data because we are not interested in price itself. Look at the return, daily return. And that's how we do the cleaning is when the data is not there, we replace by NA. When NA, we replace by NA, then we drop it. okay? And then we just to reset the index, okay? This is how you clean the data. And then you calculate the return, okay? And I think I added 1.9 here is because of the first one is NA as well. So I drop it as well because the first day, there's no return, right? Because then I also drop the first day. So that's why I add another one, which I need to run it right now. So let me run that guy. Okay, let's go back to this again. Okay. So first is, this is NumPy Panda. Actually, I don't need this guy for the moment. Actually, I don't need that one. Just this is fine. I just need to run these few lines. And then this is the data I have, right? This is the S&P 500 data. And then I drop the NA data, right? Reset the index, okay? And then I run the return, okay? And then you try to look at the return. You notice that in the first day, this NAN is because of, there's nothing to minus in the first day, right? So that's why you need to drop this as well. So I drop it, right? I drop the NA, and then this will be the data we're looking at, okay? I hope that is clear. I mean, there's some minor addition to my slide, just this particular line, to make it nicer. So the first thing to do is I do a summary statistics, discrete statistics, EDA, right? To look at how the chart looks like, right? So what I do is to set the beam width is 1, is like $1, right? Index is 1, and then I set the bins, and I just plot it, okay? The only thing I have to remind you that because the way that Python being set up, you have to add the last entry, not the max, but max plus the beam width, okay? So we just copy this guy, okay? And I hope we copy here, should be running. Yeah, that's fine. And we run it, this is the graph that we have, okay? So I hope that's clear that this is how you plot it, right? You can see that the question is being that how many days that you have more than 5%, less than 5%. So there will be the losses here, just like very small amount, but that would be the answer we have, right? If you want to know, you add up this area, it's a estimate of what we want to know, right? We want to know percentage, how likely that you lost 5% per day. Then use the historical data, look at past 11 years, around 2,000 days, 2,500 days, and then this is the number that would be the best estimate you can get, right? That's called the point estimate, right? Just what the data is the way that is our guess, right? So I hope that part is clear, what we are doing in this one, with this slide we have, okay? So turn out that if you count how many days actually less than 5%, right? You can easily use a Python to check the number and do the count. I mean, that usually able to do that. Turn out to be only 5%, sorry, 0.5%. You can easily use Python to check, right? You can use DF and LOC, whatever way you can check it, right? You can easily check this guy. And the question is, the data we said is 0.5%. How good is this estimate, right? This is what we call point estimate, right? Based on the data, okay? Is how good is it? This is to come up with the best is our best guess, but how good the guess, right? And if you learn undergrad, that is what we learn the interval estimate, right? That called the 信心区间 right? Or 对吧？信仰区间，或者是叫什么 confidence interval, right? It's not a number, but it just give him the how accurate they are, right? So, and that's the idea, okay? So the first thing to do is look at the threshold is 5%, right? And I do the counting, right? I just look at the days. Look at how many days that is less than that, right? Do you know that this is a list, right? So it is a list operation. So basically what we do is a bunch of 0 and 1, right? And then I only care about the sum of it. Sum of it is the number of days that actually is less than 5%. Is that clear what it's doing? So let me repeat again. So the first one is a number, right? This -5, right? It's lost more than 5%, right? And I want to calculate the number of days that is actually fall below 5% for each day, right? And to do it, I actually combine the code into supposed to be 2-line code, but I combine to one. First is I compare each day. Is it less than 5% or not? This is a logical statement, which means that I have a bunch of 0, 1. Each day I have 1 or 0, right? If it's true, there's 1. If not true, there's 0. All right? So for each day, I will do that. And I add up everything, means the total number of days that for that day would have lost more than 5%. So it's total number of days that below the threshold. So that is what it means, right? And I calculate how many days we have, the count, right? Just the length of the data. And this division is percentage of day. Okay, turn out to be 0.5, right? So it's 5%, 0.5% of data that should be low. Okay? So that would be our best guess. Is that clear what it's doing? Right? I mean, I would expect you to know how to understand this. Well, of course, I would not try to ask you in exam. I mean, not try to ask you, give you a code and ask you which slide, but it's not a programming class, right? But I'll expect this simple code you should be able, right? Because you're IT manager, right? It's hard to say you don't know what I'm doing, right? I mean, if you don't know, then ask AI ChatGPT to explain that to you. But I try to explain at the best I can help, right? Because I want to look at right here. I want to look at how many number of days are here, right? Right. So this is the code. Is that clear what I'm doing? Because I just try to explain a little bit. If you have this a bracket here, then you will be a bunch of 0 and 1. Okay, bunch of false and true. False actually means 0. 1 means true, right? You can put a sum there. So that would be if that's the case, then the actually is less loss is more than 5%, right? So that would be then the sum is adding up. Okay, so I hope that is clear what I'm doing here. Is that okay? So the problem, one of the problem that why the data analysis is a problem is, as we said before, the data is the one possibility that might have come up in even many possible cases, right? Because imagine we are in a multiverse world, if you believe that case, and we only observe one of the universe, right? There are many parallel universes we can't observe, right? So we don't really know what might have happened, right? If we don't observe this particular history. So, or you can imagine that, right? You look at doing a sample, you only pick a particular guy, right? You don't go to the other case, right? For example, you come to CHK, right? Suppose you're not, you go to Hong Kong U, right? Or you go to UST, right? Or you go to City U, or you go to whatever the school, right? Then you don't know what would happen, right? Which might or may not be better, right? Who knows what, right? So the question is, okay, how good is our estimate? Okay. Luckily, of course, we never know. Okay. But is there any way we can have some more educated knowledge from the data we have? Okay. The answer is, okay, somehow yes. The reason being that from the data, you can calculate the sample variance, right? The data you can variance. And sample variance indeed can be a good guess for the population variance. By that sense, if that is successful, then actually we have some idea about how good our guess is. If the data are very concentrated, for example, right? Then we have good confidence that our guess will be a good one. right? Suppose our data, look at the stop data, right? If suppose all data is like all concentrated in 0, right? Which is the case, right? So it is that less than 5% negative is not so likely. That is okay, right? So this like our guess would be a good guess. So looking at how variation in the data, we can have a good guess of how good is our guess. Okay, a little bit convoluted. It's like we make some guess, okay, based on the data. But the data is way concentrated, then our guess will be a good one. If data is way spread out, then we have less confidence on our data. Okay, so although we don't observe multiple universe, but the diversity or the dispersion of the data can help us to predict how likely the original data that the other universe going to be like. Then we can assess how good our estimate is. Okay, by making some assumption, of course, but that is the price of making some thing, because we never know what happened in the other universe. We can just say that our universe is not very special. Okay, so that would be something we are making some assumption there. Okay, so how do we do that? Okay, the theory is what we get. The sample mean and sample variance is a part of the data, so it's a random variable itself. Okay, so it depends on what you get. Okay, it's a randomness. Okay, there's something high up the population you're trying to draw. So by doing that, making some assumption like this, then it's fine, right? So the drawback is we have to say the past and the future are related in some sense, right? There's something that similar enough, right? Just like if the future is not what happened in the past, then everything fails, right? If, for example, the multiple universe, if our universe is so different from the other universe, then what you get from this universe cannot be generalizable to other universe. So that is the same idea, right? So this is just the same thinking. Imagine, right? There's always in a drama, some of the drama would say there's a lady who got cheated by her husband or her girlfriend, and then she declare every man are bad, right? 男人都是没良心的. Okay, so something like that, right? And this conclusion is valid if her husband or her boyfriend is actually a normal guy that is similar to other boys or men, right? If this particular man is very bad, right? Maybe he's a spy from Japanese army in the old day, right? Or maybe he's actually a foreigner, or maybe he's crazy. Then this is not generalizable, right? You assume that guy is actually a normal guy. Then you can start to claim all men are bad, all men are disloyal, right? Those kind of idea you can generalize, right? Otherwise, just special case cannot generalizable. So that's the idea here, same, right? Now, so that means that when we try to look at the sample mean or sample variance, it's just trying to draw from something. And how it looks like, we make assumption. Maybe there's a bell shape, or maybe not, right? When you learn for undergrad, you learn there's some bell curve that apply because of central limit theorem, right? 中央极限定理, right? That is going to be applied there if you apply. If not, then you have to make some assumption there, or based from data. Okay, but let's see that. But the key is, if the variation is small, that's okay. Okay, so let's see the example here. Okay, and we construct the confidence interval, right? Instead of guessing the point, we have to subtract at -2 SE. Okay, and the reason is being that central limit theorem apply in general. If it doesn't apply, then everything fails, but let's make it apply. Okay, and in that case, what your guess plus minus the SE, okay, would be the interval that we're going to estimate, right? If the interval is big, then your guess is not very clear. right? Suppose I want to guess tomorrow's stock price, okay? Maybe I look at the Hang Index, okay? Then if my interval is say the Hang Index will be from 0 to 1 billion, then what's a guess? It's useless, right? The guess has to be meaningful. When you say the guess may be maybe 20,000 to 25,000, right? That would be meaningful. Or maybe you guys don't know Hang Index. Okay, you A share, right? Shanghai Composite, right? So or the A share composite, right? So if I say my prediction is 2,000 to 7,000, basically you fire me, right? As a financial analyst, right? But you will say maybe 3,500 to 3,000 to 3,500, right? Maybe the guess for the end of this month, right? That may be a little bit more accurate, but probably you want to be more narrow. But that would be the idea here. Okay? Instead of guessing a single point, but we guess a bunch of points. Okay. So as I said, there are two ways to do it. I think you learned it in undergrad very well. Do it in the theory, right? Plus minus 2 SE. So what new thing we want to introduce, you haven't done so, is we learn it using a numerical method, what we call bootstrapping or resampling, which usually you don't learn in undergrad. The reason is being that now with computers so cheap, now we can do it. At least when I was undergrad, we never learned this. We just mentioned this, but we never actually can do it because the computer is so slow at that time. Now the computer is so fast, then you can just click and they're done. So later we do it. Okay, so how to do that? Bootstrapping or resampling. Okay. So the idea, actually, I said you learned it from the undergrad, right? Is the standard error of the mean, okay, will be the sample standard deviation over the root n, right? This is what you learn in undergrad. Okay, I'm not going to derive that. It's not something complicated. It can be derived, but I just give the formula because we are not math class. We just give you the formula. If you really want to learn it, I mean, I can send you the undergrad slide. It's there, but I don't think we really need to do it because if you really want to really ask me, I can try to help you, but that's not something complicated. And if the data is binary, which will be the case, what we're looking at is actually even more simple. You just take the mean minus times 1 minus the mean and take a square root. That would be the case. Okay. So now let's see let's see this. Okay. So this, remember the formula is STD, the standard deviation. Okay. And in fact, Python has SCM. Actually can just directly calculate the standard error, okay, of mean. So is standard error of the mean, SCM. Okay. So basically just STD divided by root n. Okay. So this is just follow this particular formula here. Okay. So that's why I don't want to teach this because it's there, right? You can directly obtain it from this theta formula here, right? So that will be the estimate if you want to say my guess, right? My guess is the mean and plus minus 2 of this SEM, right? Will be our best guess, right? So in this particular case, as I said, this is a binary data, right? Because every day is either more than 5% losses or not 5% losses, right? So 0-1 data, right? Because when you look at this data, although it's daily return, but for us to calculate this particular problem, because we only care about whether that day has lost more than 5%. So the data become 0 and 1, right? And this particular 0 and 1, the calculation is much easier, right? The mean is just 5%, which we have calculated. But the SC is much simple. It's 1 over root n and 5%, 0.5% minus 0.5%. Okay, and then you can come up with 14%. Okay. And then just the 5% plus minus 2 times this SC will be the estimate. So it will be like how many days then you expect if you invest in US stock market, have 5% losses, will be 0.2% to 0.78%. So this is, we want to do that. Okay, so that would be the idea. Okay, so that is something we want to know. How risky is it, right? Of course, 0.5 is our best guess, right? But if you want to make sure this is going to be, this is the best case scenario, this is worst case scenario, use 5% idea, right? So whether you accept this as a worst case, if you're okay with that, then you can invest in the US stock market, right? And the China stock market, you probably know this day, the news, right? It's like, I don't know today, but at least I know, probably know, right? It's not opening, right? Now it has been like skyrocketing, right? So the question would be, is the future going to be something like the past? If you think that what the government have done to change the market so much, then what you do, what basically based on data, will be garbage in, garbage out, right? So that has to say, if you rely on data, have to make sure that you have to think the future is same as the past, right? So then the question is, what kind of data is to get? If you say, try to understand the Chinese stock market, is look back at 2008 when JB won, right, Wen Jiabao, and he tried to inject like 4,000 billion dollar into the stock market, then the stock market also gone up, right? So you can say that period may be similar to now, then you can look at that. Right? So it depends on, even you have long history data, but you don't have to use all of them, right? Because they're not the same. So when you try to look at, suppose you ask me to forecast when the stock market open next week, I think China open next week, right? Then after the golden week, right? 黄金周, right? The 11长假. Then you look at that period, then you can see, right? But anyway, that would be the idea. Now here we look at the case where we don't rely on theory, right? Because that model, right? This model, right, is assuming that the SE, right, everything works nicely, then you can apply this nice formula. This nice formula works very well. It's a good approximation, right? But indeed, it did not be the case. So that's why we try to use data, okay, to construct another universe, okay? Is that before the data, we make some assumption to say, based on the sample variation, we guess how different universes are related, okay? That's through the theory. Now we are not fooling the theory. What we do is we have some data collected in this universe with computer to reconstruct what might be other universe. So we construct many universe, okay? And if I have many universe, right, then I'm able to tell you that how good is my guess. Okay, that means that we will create from the one history, recreate many possible history. Then we can see where the majority history lies. Then we can calculate, right? So put in this way. Remember the story. I said there's a woman who said his husband had cheated him, right? And then that woman concluded most of men are bad. 95% women bad, say, for example. So how do we do this in this history? Means that I take this guy's DNA, okay? Suppose I have a machine to create 1,000 men, okay? And let's see this 1,000 men, how many of them are cheat, right? If more than 950 men cheat, then we conclude men are bad, okay? That's the idea. Is that clear what we're doing, right? We are creating many possible universe and see how many days actually is more than 5% loss and average of those, okay? That we were done in the data, okay? So of course, there are many ways to recreate the history. Okay. One of them we do is we just close our eyes and take the data and do the data and then look at the standard error. So let's directly do it. Okay. And we'll design how to construct the sample. Okay. What we do is, because we have like, how many days we have? I think we have 2,500 days. I think the data have, if I remember correctly. How many days we have? The data is 2,500 days. Okay. So, but we're not going to reconstruct the history. We just look at 1,000 days. Okay. The reason is being that we just fix something. We just not create the whole universe. I create some small universe only. Okay. I create 100 days. Okay. And of course, I would not have just, then I calculate how many days that more than 5%. Then I record the number there. Okay. But I not only create this 1,000 days, I create 10,000 of this. So I have 10,000 of 1,000 days. Is that clear? Okay. And then I'll calculate how average of those they have 5% loss, which should be same, upon 5%. And I look at standard deviation of this, which is around 2%, which I will do it. Don't worry. I'll do the Python code for that. But just tell you the answer first, and we do the Python code. And then I can calculate how accurate it is. Of course, that will be much larger. In general, when you recreate the universe, usually this is too bigger. Okay. Okay. But let's see how we do it in data. So hopefully that, okay. What we're going to do, I'm sorry that I said I have no code, but I'm sorry that we need to have some coding here to make our life easier. Okay, you don't have to write the code, but let's okay, don't feel too bad. It's not that difficult. So you'll be I will slow. After this I break. Okay, so make sure that you don't feel too bad. Okay, first line, no problem, right? Lumpy. Okay. Now what I'm going to do here is slightly complicated. I think you have learned it, but this is a define means a function. So it's a, I think there's only several times we have some real programming, right? Well, because when you learn programming, what's the main thing? Programming, the first principle is what? Hello world, mate. But what's the first principle writing program? Is never repeat yourself, right? Have to write the smart programming, right? So that's why program means that we can reusable, right? So we keep using this one, right? What is doing here? The resampling is taking 3 elements there. X is something that the history of the thing, and you're asking how many times you're taking the sample and how observation you take, right? Remember, we're going to look at back here. We are going to take 10,000 of the sample. Each time you take 1,000 days. Okay, so this is number of sample. You have the 10,000 of them. Each sample you have 1,000 observation. Is that clear what I'm doing here? Okay, so what I do is I will start a big sample is a list, right? Probably you should be comfortable the Python right now. And what I do is, I'm sorry, we have the for loop, okay? And because I have to keep getting things, right? We need a for loop, okay, with a for loop. And the for loop, because I don't really need the counter, so I use underscore. That's a Python notation. I mean, I think only Python allow this crazy thing can happen, because other software, I think you have to put something here, but because we repeat, what I do is I actually getting how many sample I'm getting, just repeat, right? For each sample, I do the following, because I have repeat this 1,000 times, right? So that means that for each universe, I'm going to do this, right? Because I construct 10,000 universe, and each universe have 1,000 subjects, right? 1,000 days, right? So what I'm going to do, the sample I construct will be based on a function, the numpy is called random choice, which is I have, say, 2,500 days of stock price, right? I take out how many of them, okay? And I replace false means I don't do it with replacement. If I take true, then we'll be doing that with replacement, whether with or without, up to you. There's no particular reason whether you use true or false. It's the choice. And if the 2000, I think doesn't really matter anyway. So here I have the false, right? So what I'm doing here is, okay, I'm asking the program to construct 10,000 universe. And for each universe, I'm going to look at my original data, original universe. I take 10,000 days, okay? And I take it without replacement, means once I take, it's not going to put it back. Okay, I take 1,000 days from the data, right? Is that clear what I'm doing? So let me repeat, you have 2,000 days of data, okay? I'm going to create 10,000 multiple parallel. For each universe, I'm going to close my eye and pick up 1,000 days, okay? And I pick it without replacement, means I close it and pick. I don't put it back, okay? Then the sample. But I don't need the data. What I need is look at how many days the loss is more than 5%. So what I do is I add up. So this is the first thing. Remember this guy? This guy is how many number of days? I look at the sum, right? This is exactly the number of days, right? And I over number of observation, which is percentage of days that is more than 5% loss, right? And I pen to it means that for every universe, I only end up, I construct a universe, I can count how many days that are more than 5%. I calculate the relative number to that, right? And once I do that, I would have 10,000 entry, right? Each entry is telling me percentage of they that have more than 5% losses, right? Then that is the function I'm doing, okay? This is very generic, right? The only thing not generic is this guy, right? So this is something to do calculation. So if you really need to do calculation, you have to change this part, right? This is 5% losses. It can be anything else. You will care, right? Then after I did that, right, you return this guy, right? So then I would have a random seed because I do randomization. I want the randomization is actually repeatable, right? If you learn programming, random is not really random. Unfortunately, so far we don't have a good random thing for computer generate, right? Because in philosophy, computer cannot do random thing, right? They actually still, in some sense, are okay. The method of random. I mean, you need the programming is like in classical case, a random thing is there's a paper, and you just depend on the date, month, and time. You pick up the point on a table. It just go a random spot, right? So that is called a random. It's not random. It's actually deterministic, right? Those who believe horoscope would have no problem with that, right? Because people would say, okay, this is Leo, 狮子座，对吗？羊马座、天子座 whatever, right? And then that would be related to when you born is random time, right? But you believe that actually there's a high order power determine when you're born, then what kind of fortune you have. But the random is like this, right? You tell them initial. Then here it's like I do the random. Okay. And after that, you calculate the mean, right? You calculate SD, right? This SD is the standard error, is a standard error, right? Because you calculate many universe. The standard deviation is actually what should be the standard error. Okay. And then you plus minus 2 of this will be the thing you want to look at, right? So that is how you get 0.1 and 0.9. Okay. Let me run this and then we have a break. Okay. To make sure that you're happy with that. So what I'm doing, right? Just have to be, so you can see I'm here. I have to make a tab. Okay. It should run. Oh, outside function. I forgot tab again. So you take some time. Oh, it's very fast. I thought you take some time, but you take 1 second, right? If you imagine 10 years ago, you would take, I think it at least would take half an hour to do it. Oh, error is like this guy. Sorry. Like this. Okay. So you can just, what is left and right? And then want to do that. Okay. You tell us what is left and right. I mean, of course, slightly different. It's 1, 6. Right. This is x, 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 right? Okay. So that's tell us if you're able to construct different universe, of course, we're different. Okay, of course, you can play around with this. I mean, there's no particular reason why I only construct 1,000 and 10,000, right? You can say, I have fun. I want to change it to 2,000, right? And what is here, then you can do the calculation, right? When 2,000 is more accurate, smaller, right? The range become 0.3 to 0.6, okay? And the good thing about this creating universe is good is because if you care anything that is crazy, there's no math you can derive, you can still do it, right? Because look at this. This is the part that we create many universe, right? So you can calculate whatever thing you care, right? You can care different quantile, you can care some very crazy thing. Maybe you care about mean plus 3 standard deviation, what's the number, right? Maybe you care about very weird stuff, which may be important because you have care some score or whatever thing you care, right? But in that case, it can be compute, right? And then you can look at this and you can do calculation. So that's a very convenient thing. In the old days, I mean, we're limited by the math technique, but with this technique, no matter what you don't guess, based on data, you can recreate as many any universe you can create. Then that can come up with multiple possible universe, can tell us how accurate your measure is, and then you can have good guess. So that is very convenient because it's not accessible in old days, right? I guess in undergrad, they don't teach you this. Or I don't know, maybe some of you did, but I guess most of undergrad class will not talk about this. At least when I talk our school, we don't teach this, okay? So this is reserved for the master level because this is what we call the resampling method, okay? And after the break, we'll talk about another method, okay? This method is related to what we see. What we have just saw is just recreate 1,000 days, which is fine, but it's not the whole universe, right? We just create many small universe, right? After the break, we talk about bootstrapping, which is reconstruct the whole universe. So it's more computational heavy, but this is now, because computer is so cheap, this is the standard technique. The resampling is the method that is when your computer is not fast enough, you do that. But when computer fast enough, you do that, bootstrapping. But do know that your IT manager, very likely that your data is so large that you can't do this method. So that's why I still want to teach that, because resampling is probably the way you do when you work for a company, right? Suppose the data of the customer base for JD.com or Tmall, Taobao, you have like several billion. You can't really reconstruct 1,000 or 10,000 of this. It's like your computer just die. Even your supercomputer, it doesn't work, right? You have to do resample anyway. But when you actually work on some project that is small enough, then you use bootstrapping later. You will see the same method, but just recreate the whole universe. Okay, we look at the code after the break, but as you can see, it's not complicated, right? So because the same logic, but you're just not creating small universe, but you create the whole universe. Okay, but let's have a break of I guess how long? 10 to 15 minutes time, maybe 12 minutes, and then we come back.
我们也是，我一个平衡调理，英国一样。我感觉是加拿大的也做 ID 的 ，IV 用啊，行政这里方面。最大的，什么？他玩的是吧？啊。但是他们学这个好像又有 IV。我忘了那个分享。我俩也肯定知道 I 的呀。我俩都没。看一眼。那我对你那个大了解。看看。对，其实学那个就欧定我是对。就是当初是这个。结果他还是比当时好像是这样。加吧标的，好处就是过家家。我们也是。完全看到，但是我没办法嘛。管理。老师听走过来有可能。哎，刚才跟你讲话。我觉得你还可以像是你觉得哪个好？你觉得这个老师还是哪个？我在加拿大根本不知道这个，真的，我当时天天哭，我操，我舍不得。哎，那人生，哎，你这个建筑，我们经常遇到一个点子说
那个那个粥就是个上。
啊，上这种，
这相当于
是吧？啊，我觉得在加拿大或者在加拿大或者美国，小时候或者这个样吗？我觉得很喜欢。
另外那个看到我们一起被人家晕的感觉。然后刚才有一个对打这个。会喜欢有拜拜，因为不积极的，喜欢有积极的。
哦，就是特别大的一个中国同学，特别大。
我才是拍了，虽然还没给追的，他不要拍。
也不是过
过完上来。对，我们这里是会上的重点。我说嘛，
我在加拿大不了。
现在在上海，我应该没事会好，所以应该不会短期马上上就会想。
其实就是你们就是享受着。我男朋友他去了英国，他也不让去。英国人真的不行，这个是做气不友好，就是有的然后他们有
还上了报，他有一个回归做回归，不同的参数，然后他们有一个回归，这样的差不多。
我是没有，所以
对，但是就是他已经到过，他是一个他长这个，在那个中大，有长他没看，这样的已经呢，不进去，也有这个，还好，有些他说。刚才所以他说他打了他东西，说天空分都想，所以还有可以找那个新想题目才知道，那个谁知道？就是他那个那当时跟你他说看嘛，那个怎么分？那种类似，但是这样不是办法。
你收回你刚刚的承诺。
有晚上看那个，有表现。
比这儿多，
没有，
比国内多。
有大小，有电视看
啊，我是就是卷。
然后就是还是
这个好一点，但是但是我觉得
以前我们幼儿园的，
但是现在不能加上现在安排啊，你们艺术人员，
从小就搞法。
哦，咱学校不是，就是那个看真的那可能还比饭那么牛。
20年前我还是黑人都，
哦，你知道
他那个被看掉，
他们看上可能更舒服。
现在看的，因为我们会有跟那个 AI 做分享，也可以找那个。有会放，你早上把它的码走出来，都拍一点，然后 video 也可以说 AI 那个有现在那个拍过程，过程完掉，把它的 video 出来，应该可以。那首先你可以做，我相信你们8年有能力可以不然，但是我觉得不搞这个了，确实我这有点。或者说我们看起来干嘛？快把。
我选上我就觉得他们刚刚想。
看那个封面有的时候太强很大。
我真的，哎呀，我当时怎么真想的？其实我在街上买的，倒没有，我就是很舍不得，你知道吗？真的很舍不得。那我就跟你老师，你想念哪个？你想念波士顿吗？
波士顿对，波士顿挺好的，波士顿龙虾很好吃，很便宜的，但其实10块钱一个龙虾，现在就比较贵，现在要20多。那龙虾是还有我
西红柿炒鸡蛋。
当时我读书的时候，陈冠希老师还去那边超市买菜的。你看到了吗？我的同学看到，我没有看到，但是他们就看到陈老师。我没看。但是哪边还是不错，那边还是挺安全。而且那边高等大学校。对，MIT 啊。我觉得那边没什么好，问题是没什么好吃的啊。我觉得香港开心。对，那边去有些西餐的。有饭，对，饭是墨西哥饭。你习惯吗 ？burrito 那个东西，我觉得是老实说不习惯。之前在我最喜欢吃的这个是港式，好像你就进去食堂，然后一个那种港式，然后一个饭，然后那个排。对，所以吃的不常好，再去到美国的大部分留学生都会做饭。那个你没有对吗？今天好像很多，现在好很多。我差不多10年前嘛，现在好很多。现在已经全世界都是这种。
哦，对，没错。
我记得你们上过比较开心的，有饭吃的吗？不爽就是一言不合就直接去深圳就好，没有饭吃了，对吧？没有什么问题。不爽的去深圳，对吧？对，期待嗨一点。So let's see. Thanks for your comment. Let's see what. Yeah, it's very useful to resampling. Just to remind you that it is a new way, and then I would expect that is something very useful for you to have a guess, right? You have the data, you want to generalize the information from the data to a general case. Then math formula is very difficult often. So you can create multiple artificial sample or create parallel universe and draw a conclusion. That I think is very useful tools. I hope that you can use it. You need to return all the knowledge to your professor, which is very normal, and also return everything to my teacher as well. If I'm not teaching this class, probably I will forget, but the content become. Do note that we are not math class, we're not stat class. We don't expect you to know anything, right? That's basically this is the formula here, you know how to apply, and that'd be good, right? Because the thing now is like you already passed undergrad, it's a graduate level, right? So no one expect you, at least for my class, I'm not expecting you to remember anything. You bring your laptop, you can bring your cheat sheet to exam, right? You can look at everything when you do your assignment, right? So what I need you to learn is to learn the principle, the idea behind, and how you can learn immediately, right? It's how much thing I can teach in 12 weeks, very limited, right? But basically, I teach you how to learn. I teach you the basic you can learn further, right? The classical Chinese saying, right? Give you a fish is not good as give you a fishing tool, right? Teaching you how to, right? 授人以鱼不如授人以渔, right?
So that's the same idea here, right? So I can't really teach you everything, right? It's very difficult. But I teach you the basic, you can go further. You can understand the logic and you can go further. So that's the main idea here. Do I speculate stocks? Okay. Yes, I did. But I don't do it anymore. Because now the saving rate is 3 or 4%, so I just put all my money into saving. And that being said, because in Hong Kong, your 15% of salary actually go to the retirement fund, and the retirement fund I go to max risky portfolio. So that part I just very risky. And for my own money, I just don't. And just a personal note is because my wife is doing a lot of risky investment, so I have to be safe, right? She do all the exotic investments. So I just being a safe. And you need someone to be safe in the family, so I just do the safety choice. But she do all sorts of risky investment. And yeah, you're right that if you try to invest, then it's a good time right now because the market is like swinging up and down. But I would say the first thing I teach when I teach finance class is the first clause of finance is what? There's no free lunch. Risk and return must be trade-off. So there's a high return expected, must be associated with high risk. The market is efficient, right? It's not free money. Although you're earning a lot of money, but you have to see there's actually a lot of risk you may not aware of, right? Unless you have some advantage, right? You have some private information, right? Because very simple. If the price is expected to be 15% or 20% more tomorrow, if everyone knows it, the price should immediately go to that one, right? Why you take a long time to get there? It must be possible to go down, right? So it cannot be 100% sure the price will go up tomorrow. So unless everyone is stupid or you are smarter than others, right? You must be involved some risk, right? Riskless investment is not there. So taking some, of course, it's possible there are a lot of chance to earn a lot of money. But yeah, that can be that, right? I think there's a very famous quotation these days I read is some investor in China said Warren Buffett is nothing. They said, but Buffett 就怎么一回事? Because now the stock market goes up, people are very confident about the investment. But anyway, so hope you enjoy, and then if you invest, you make a lot of money. Don't forget your friends, right? Donate some money to CHK, right? And your hometown, right? Or your family or what. If you make a lot of money, don't forget your friends. Of course, you shouldn't forget your teacher as well, right? Donate some candy to me would be great. Now, so we have something outlier. So this is a good example. So if I have this, so what am I going to do? Are you going to kick this out or not? Suppose you don't know which day it is, right? So I don't have that. You ask everyone what day is today, then you get this data. So what do you conclude? Are you going to drop this one or not? You drop this, okay? Why? Right? Outlier, okay? So if this is one is outlier, what about 3 of them say it's Monday? Do you drop it? At what threshold you want to drop it? So suppose 10, you will drop it? No, so 5? There's no right or wrong answer. This asks you your preference. There's no right or wrong answer. Not, right? 3 is not. 2? So what you do is almost exactly what we say 5% rule. So they call the 5% is like 5% winterizing or 5% trimming. This is the 5%, right? Or less than 5%, you just outlier and drop. So, but you can check it out. 5% winterizing or 5% trimming is how you drop the data. I didn't talk about those, but that can be something that you may want to know. Fortunately, the weather is we have 9 minutes. Yes, that is very concise summary, right? If you repeat anything, you can try to obtain what would happen in other universe, and then that tell us how the best guess of the future looks like. If you think the data we collect can represent something may happen in other universe. As I said, for the stock market, if you believe the future looks like the past, which I don't believe for the moment, right? They use, no matter what data you do is going to be wrong, unless you're looking at something similar, right? In 2008, right? Also, the government inject so much money there, that may be there. One man cheat, all men cheat. Yes. So if you try to conclude that, right, based on experience, you have 3 men cheat, then you conclude every man cheat, right? If the data is representative, okay? Because if you have 1 data point or 2 data point, right? Suppose the case is like this, right? A woman being cheated by the first guy and cheated by the second guy and the third guy, and conclude every man cheat. If we do resampling, no matter how we resample, the sample is all man cheat. So no matter how you do the resampling, right, how to pick it up is okay, right? So again, this is a good example of garbage in, garbage out, right? This garbage man in and come out, the answer is garbage out, right? Yeah, bootstrapping later, which is important way to test the data. Oh, okay. Good to tell me that this is called 计算区间. Okay, that's good. Yes, it's coming soon. Yes. Current SE. One that sunny day. Yeah, that's interesting. Yeah, good. So I guess you can pretty much people can grab it, and overall it's okay. I don't know it's too fast or too slow. So, but I look at 6. It's okay. It's still someone say up to too fast. So I guess so. Because horse racing, suppose there's no cheating at the beginning, the background, so it's representing how the horse is it and all the information there, right? And as I said, there's a well-known formula for horse racing, right? So I would say yes, okay. But the problem is, if enough people doing the same thing, then you can't earn a lot of money, because the horse racing authority, I mean that one will adjust the odds very quickly if you bet enough. So how you can make money in the stock market, right? The smart money win the dumb money, right? If everyone is smart, then everyone become dumb, right? You have to have some dumb money to get expense of, right? Lao师谁发明的你啊? Is there some joke there? I don't got it. Is it some song or what? Someone can tell me what is fun of that one? I don't know. Maybe. 不是新兴区间，是地心区间. Okay, fine. Which restaurant in Swiss is most delicious? Depend on what type of food you try. But I think if you like Shanghai food, the Heseng is pretty good. Shanghai food. If you like the Western food, then our B school actually has one of the best if the Western food. Coffee also very good. The first floor of the CYT building. And if you like the kebab, I mean, probably it's the one that next to the Xinghelou. And other food, yeah, it's okay. It's not something. It's not. I would not say it's okay. It's not really exceptional. But undergrad, people said the UC canteen is very good. And I think one day you replied this and they said, UC canteen is the best, no objection. So I didn't try it, so you can try, but that is what I know. And the NA canteen, but I don't know you can get in, but because it requires membership. That one, the noodle is also okay. But yeah. Light color. Okay, I will try the light color next time. I think red. I guess last time you said red. I think the red one. Okay. Happy to you as well. No, yes, none. Tired. Are you interested in weird change? Oh, of course, I do. I do, and actually, there's a lot of academic study will be done soon. I'm pretty sure. Always there's some big changes that will be something to be studied there. In particular, why particular stock is going to be bought, and in particular, I have as an economist, one interesting thing is many small investors going to buy the stock, and there are many news saying that they want to remortgage their house to get the money to get in the stock market, or they borrow from the bank. But at the same time, many majority shareholders are selling their stock. Okay, so the question is, who is chives? 谁是韭菜? So I don't know, or who, I don't know. I mean, you believe who is going to be right, the majority shareholder or retail investor? I don't know. That is something you have to think about it. I mean, but I would say this is now the current stock market is so volatile. As I told some of you, I would rather go to Macau, right? Go to Macau to casino, big or small, and done. No need to worry because it's like easier, right? But to be honest, I think you can actually not paying the stock, but doing the option may be good because it's highly volatile. Right? No matter up or down, you bet on the volatile market. That may be something you might be doing. That would be easier. Instead of just buying up or down. I would expect this as a very volatile market. So if we're able to bet buying the option strategy that try to bet on the volatility, that may be a safer way to bet rather than just bet up and down, because I can see this very volatile market. I don't know. I mean, I don't have enough information to have educated guess on this one, because using bootstrapping or resample is not going to work, I guess, because it's now things are so complicated. Okay. So now let's continue this bootstrapping. I hope I give you the answer. Bootstrapping is, just I said, it's resampling, but you resample the whole universe, reconstruct the whole universe, right? And do the same thing. So there's nothing new here. But of course, you can see the only drawback is you can't do so many samples, right? Before we can do 10,000, but now we reduce to 500 to 10,000, to 1,000. So this is the graph. Suppose I have data 1 to 6, right? You can calculate some mean or variance, whatever thing you care. But bootstrapping means that I do it sampling with replacement. So I can end up in 2.4 and 2.6, right? So that is somewhat different, right? And when I create many universe, right, I can do the same as what the resampling, right? There's nothing new, but here is the only difference is I have the same number of observations of original data, okay? And I have to some sacrifices to make the sample size. Number of sample is less. Now, here's what I do. So this is example. Maybe I can skip this example because I can directly go to the case of the stock. So I want to do 10,000 bootstrap sample. Usually maybe we'll do less, but in this case, I can do 10,000 as well. So each one has the same number of the observation, 2,500. Okay. And you can calculate mean, median, mean, max, and SD. The SD will be the SE. Okay. And then you can plus and minus, oh, sorry. Of the 2 times this, sorry, I forgot the 2. Okay. 2 times this one. Okay. You can see the same code. Can you, so now let's play a game. Find out the difference between this line and the slide before. Give you 1 minute. 找不同. Look for a difference. Compare. Can you find difference between slide 31 and slide 24? Look for difference in terms of code. Okay. Can you find the main important difference? Of course. The main important difference is this one. Before is 1,000. Now is the size of the thing. Right? So I hope you have fun for 1 minute game. It's okay. See the difference? There's a bootstrapping. There's nothing new, right? See? And of course, I have replaced it true. There's a second one. Okay. Have to be true because if it's false, then there's nothing new can be done here because you collect the whole thing. Have to be true. This one we can't turn it off. Okay. For the resampling, you can turn it off, but for the bootstrapping, you have to replace it back. You cannot close your eye to pick, because if you say false, then every sample is the same. Okay, so there's only two. I mean, this and this. Okay, and you can do the calculate mean, median, SD. You can plot a graph. I guess I don't need to run it for you because I think this is very standard. I hope it's okay that I don't copy and paste every single time. Otherwise, it's become a true kindergarten style. All right. So I guess it's okay. I just don't do it. If you want to do it, you can do it again. I mean, but at the end of the day, you can know I have the standard deviation of the bootstrap sample. That is the U plus and minus 2 SE would be the thing. Same thing. There's nothing new here. Okay. I'm not going to copy that code because it's wasting your precious time, right? Because you spend so much money for this program, right? To get a master's degree, of course, you probably don't care about my class, but anyway, I have to be responsible, right? So, I mean, that's okay, right? If you, any case, you don't know, you can run the code and ask me why there's a problem, but that would be the idea. Is that okay? I skip it, but if you want to work it out, you can work it out. Okay, because I want to save time to do more important thing, right? Is that okay? I mean, I don't, because the same code, I don't want to bother to run everything again. I mean, if you want to run, you can try it at home. If you run encounter any problem in the code, you let me know, but I'm not going to run that. I think it's the same thing. But you can see the now the computer is so convenient and things very simple. Okay. So I think I want to touch this particular part because this is very important, right? Because we're attempting, we collect data and we calculate the thing we want to calculate. And that data, you calculate the stuff is, we try to say this is something that might happen in the future, right? Or that may happen when we actually implement this, right? And of course, you have to be very careful whether the sample you got is going to be useful. The first is time. As I mentioned, is the past and the future are similar, right? Is it sufficient the same or any structural difference, right? And then would tell us actually what the time period you would do, right? In many finance research, what I do is you sometimes have to avoid financial crisis period because they're different, right? But sometimes when you consider risk in your investment, then have to include those. It really depends on the type of problem you want to study. right? So maybe IT, right? When you consider the case where how many bandwidth to save, right? Then for a normal day, then you have to look at the data that is not in the promotion period, right? You shouldn't take 18th of June or November 11th in your data, right? But when you consider the peak performance, the peak bandwidth, then you should consider those days, right? So it really depends on what kind of data. I mean, at least the data have to be comparable to the thing you want to guess, right? In that case, that would be important. And you look at the location, right? You're supposed to collect data from Shanghai, then is it going to apply to Shenzhen? When I get a Shenzhen, it's going to apply to, say, Sichuan, right? If you get a Sichuan, it's going to apply to India, for example, right? These are the problems that have to be careful, right? Just like the leading example, a woman, right, may be cheated by men from the north, right, or northeast, right? 东北人骗她. So the question is, he go to Shanghai and meet Shanghai men, right? Or maybe he beaten by the Shanghai boy, right? Because we know, I mean, not going to discriminate, but it's well known for some time, 东北男的 beat woman, right? And the question is maybe that lady get beaten by several times. Then he go to Shanghai, right? Then it's going to apply, right? Probably not, right? Because Shanghai man is always got beaten rather than beating, right? Right? 香港男人都是可以打的在家里面. So it's opposite case, right? So then you would space is important, right? And subgroup is also the same, right? If the data is getting from the man, it's going to apply to woman. It's not so clear, right? So have to be very careful. And so that means that actually we don't talk about this, but when you have IT data, that means that you have so much data there, but you never use all of them because, I mean, for computational reason or time reason, you can do them. Then you mean you have to select observation, randomly selecting an observation, right? That is right. You have suppose you have 1 billion data set, then you can't really possibly every time you have 1 billion data. So maybe you select 1,000 of them. Then how to select? Then have to be you're selecting in proportional to the data set, right? Suppose your data have 40% male, 60% female. So your data to be selected, subselected data have to follow some space and subgroup characteristic, right? So your selection, you look at the mean, is it going to follow what the data you have, then to be representative. So what I meant is, suppose your whole platform has 40% male, 60% female. So if you subselect the historical data, make sure that your data also have 40% male, 60% female. Okay, so that is something that you should be careful. Okay. And as said, if you look at IT data, because data is so large, N is like 1 billion or whatever, there's actually, when you do interval estimation, that is actually as point estimation because CI is very narrow. So what we are saying, if you have very super large data, that's actually there's nothing. Okay. Okay. So that is the reason why you probably want to do resampling, not bootstrapping, right? We just let 1,000 data and reduce. Then we can have CI will be something meaningful, right? So that, and also you remember what we drawn here, the sample bootstrapping is random. As I said, random is not the best way to do. I mean, because of you want, when you do, you want the data to be representative, right? So probably you may want, if I said, say, male or female, right? In that case, you should say, for example, the simple case is you separate data into female and male, and you draw 14% from the male and 60% from the female, and combine them and do the calculation. That what we call stratified sampling will be better than just this standard random sample, because in that case, you respect some certain characteristic. Okay, but of course, that would be much more advanced topic, but try to tell you that this is not the end. Okay, there's a lot of detail you should go in order to be applied to your data, but the overall concept is the same, right? You just reconstruct the universe. But how can you reconstruct the universe? You cannot be all female in the data. Cannot be all male data. Otherwise, it's not very useful. Okay, that would be something I would want to say, right? Is that okay? And I don't have much more to say for this chapter, so we go to chapter 6. If you don't have anything more to say, right? Because the data we have, we want to generalize, is what we have done. We tell you to do it, right? The data itself is already tell you some story, but we want to say, because there's not accurate enough, we have to construct interval CI with the thing that actually we guess. Okay? So we done how to do it, right? We learn how to extend what we learned by constructing CI. So that is the thing. Okay. And okay. Now next is what we call hypothesis testing. And don't worry, this will be very short. Okay. Of course, philosophically, this is very deep. Okay. But we are not philosopher. Okay. We just tell you some procedure how to work on this. And most of the math we will just say bye-bye. We just telling you there's some special rule to do it. Okay. Because if I want to teach this carefully, then actually 1 semester is not sufficient. So how can we do it? So that will be something simple. Okay, we rely on the output of computer, and then we just make decision. Okay, and you may ask why we want to test hypothesis. The thing is, okay, now we just seen what we've seen is we have the data, we try to calculate some measure, and we try to see, okay, this would be whole for the general data by using confidence interval, right? That is very simple, right? We just have one step, right? There's nothing behind it, just the data, the conclusion we get from data, just go to what we predict in the future. But in general, there are more than that. We'll estimate model, right? Say regression model, machine learning model, okay? To get that model will tell us the prediction. Okay, let me draw a diagram to tell you what we're doing. Let me say this is the case. Okay, what we just say is, now this is the universal population. There's no pen. Oh, there's a pen. Let's see if this pen works. Population here, right? So remember what we're doing is, okay, we have some sample here. This is what we get. Okay. And the previous topic, we say, okay, there's some math. If you do, you can, from there, you can guess, right? Say SE will be, say, 1/√n of the SD, right? That's something you can guess, right? But in general, this link is not possible because of the math requirement is too much. We can't do for every possible thing. We care, right? So what we're going to do is, okay, instead of doing the math technique is from this sample, we create many hypothetical sample, okay? By the data, we construct this fake universe, okay? And looking at how this fake universe behave, we improve our estimate. This is what we learned, right? This is what we just seen, okay? But this is something that directly from data. Very often, seems like everything is off. Yeah, why? Is it okay? It's off, or you're hot or not? It's 25.5. It's okay? Fine for me. So what we're going to do is not doing this directly, okay? Because we don't want from the data to the conclusion directly. Usually we don't do that because because that means every time we have to go to the data. Okay. So what we're going to do is have an intermediate step. We will do is from the sample, we actually get something like a model. What the model is what we call, in technical term, this is called data generating process, or what is underlying mechanism, or what's the black box behind. How you observe the world with some black box that create the data, right? Maybe say X and Y, how they generate is coming from some function, some related, okay? And we try to guess this model, and from the model, we can fit to here, okay? So the question is later, you see, using the data, we try to estimate model. And the model, of course, has some parameter or some number, 参数, right? There's some number you can guess from here to there, right? So, but the first question is you get some number here, right? And this number have to be meaningful to be useful, okay? So hypothesis testing is a step that makes sure that the number you get from the data is meaningful, okay? So that's the idea why we do hypothesis testing, is to make sure that the thing we get in actually useful. So that's why we do a lot. I mean, basically, this is the rest of the semester is to introduce you different model from data to the blue, to draw conclusion from the blue, right? Because this model tells us how all the other part is being generated, right? And different model, and how from here to here, there's a Python. Python will tell you here to here, right? But we just introduce you different type of modeling, right? But once you estimate the model, you want to make sure that this model is actually a meaningful model, okay? Not coming out of randomness, right? Because by randomness, you can always get something, right? But anyway, it's still very abstract, but don't worry, we will go to more detail because this is something we do for the rest of the semester anyway. So, but that is the idea. Not sure that I convince you anything or tell you any content because it's too abstract, but hypothesis testing is basically using data to make decision. Okay, because at the end we have to make decision whether the model we use is a right model or wrong model. Okay, and in the simplest case is, okay, hypothesis testing is I try to say about the value of statistics. I say about the mean is that value or what value, okay? And this S is true, or the true value is called S true, the estimated with S hat. So very often, may not be IT, but say, for example, for this pen, okay? For this pen, they said is non-toxic, okay? You can check, non-toxic. So it said usually it means that it is absence of certain material, or certain material is below, say, 1% or what, right? And we say things are, say, organic, right? If less than 1% is having chemical, right? So there's a question we want to test this claim is correct or not, okay? This is the simplest thing you want to study, okay? And in hypothesis, actually, when we estimate model, very often we want to say the parameter is meaningful, or your model is useful, right? That means the parameter value is not zero, right? Because parameter is zero, that means that the model doesn't help you. The model input doesn't have any impact on your data, on your output, right? Because usually the model, right, you fit in something, you output something, right? If the parameter is zero, means that your input doesn't really matter, just output something, right? Because to be more concrete, right? Make you more concrete is like, say, let me make it more concrete. So the concrete case like this, right? If you have X and Y, right? Regression model will be telling us, or to jump ahead a little bit, right? Regression model is like a bunch of data, right? Regression is telling one thing, it's just, I want to draw a line that's best fit this data, right? That's not regression. Sorry, I jump ahead for the next class, but this is what we're going to do for the next week, right? It's that trying to draw a line that best fit data, right? Trying to X to predict Y, right? Or X explain Y, predict whatever you like, but that's one, right? And the thing is, I want to look at the slope and intercept, right? Especially the intercept, right? The intercept is called this beta, right? It's called, and this slope called alpha, right? That will be alpha plus beta x, right? Will be the model, right? We have a data. We collapse this data to a simple model, have two parameters, alpha and beta, right? Alpha, of course, not very useful parameter, doesn't really care, but the main thing is the beta, right? And then we want to test whether beta is 0 or not, right? If beta is 0, that model is useless, complete useless model, right? Because X has no impact on Y, so it's gone. So that will be the same we want to study, okay? But of course, before we do that, we want to see how to do in a generic way. But this is the thing that we will study for the rest of semester, because it's a linear model. You can do any nonlinear model. You can do Weyer's model, but this is something we will do, okay? So hopefully that I convince you that what we're doing now is very important, okay? Why we spend time on this thing, why we want to care about this is 0 or not 0, bigger than 0, negative, why they're positive or slightly positive, right? That's important, okay? So this is the undergrad thing. The simple one is equality, and in our class, it's always simple. Whether 0 or not, that's we care, okay? And the alternative is composite. We always this guy for us, okay? Whether it's equal or unequal, okay? And in our class, it's always this guy, two-sided one, okay? We're not going to talk about this. It's beyond the scope of our class, which is what about. We just see whether data support 0 or non-zero. Okay. That is, so that the only thing we care is whether the slope is, say, 0 or non-zero. Okay. And okay. And for some reason that I can't explain because of math problem, is you would assume at the beginning your model is crap. Okay, you will assume the null, which is our hypothesis, is 0. So your model is crap. Your model is nothing. Only if your data support otherwise, then you will say your model is useful. Okay, just same as the case in Chinese legal system. Everyone is assumed to be bad guy until you prove you're not bad, right? You're not innocent. You're guilty. You have proved your innocence, which is opposite the case in the legal system in the US or common law in Hong Kong. You assume innocent and until proven you're guilty, right? So it is which way I don't know which one's better. I can't say, but that is a difference, right? Either you put not equal and equal, right? But in the hypothesis, we assume the model is crap, so you assume you're guilty. You have to prove your innocence, okay? And you ask why. There's a math reason behind it, but I'm not going to discuss because it's very complicated. You can do reversely, but this is something that never covered in undergrad. I don't think even anyone would do in the graduate level. That would be something very complicated thing. But this is standard we do. Okay. We assume your model is useless. You have to prove, you have to show me your model is meaningful. The reason, of course, philosophically is because every data is so random. So something can pop up if you pick up some particular data, right? So we have to have you have to show me enough evidence to show this is true. Same as the reason why we have the court system in Hong Kong, why you have assumed people, the common law, right? Why you have to prove that, why you assume people innocent, and you have enough evidence to prove one is guilty, is because we believe that government is too powerful. If the bad guy is the prosecutor, he can always sue that guy, right? And normal people don't have money, right? So that means that you have to prove with enough evidence that, and then you can just sue them. Just, I don't know whether bad or not. I mean, but that is a system. Okay. So in our class, we focus on this one because this is something we care. In the simple cases, we assume the population mean, mu, is A or not equal to A. But you can imagine this regression parameter whether beta is 0 or beta is not equal to 0. Okay. And turn out that this is very similar idea is you collect the data, sample mean, x bar, minus A over this standard error, which is 1 over root n of the standard deviation, which we learned. It's going to follow the t distribution, okay? Under very strong assumption, okay? And don't worry, we really don't need this kind of calculation, but just I keep it there. As I said, we are not stat class, so I just put there because this is you learn it undergrad, right? 这个学生分布没有学过吧 ？T 分布，学生分布，学生 T 分布，所以就这个。So don't worry, with regression you will see it again. Always we see that again. Okay. So the decision to make is okay. Based on what we call critical value method. Okay. So the idea is that it's very simple. Okay. You claim the mean of the population is A, right? And I said, if not A, then anything is not equal to A, then I will reject, right? So it means the following. If my data is very close to A, then I don't have enough evidence to reject it, right? If my data is far away from A, then I have doubt on whether this is correct, right? So if far enough, then it's fail, right? So that's why the critical region is to define how far away that I will going to reject. Okay, but I will give the more specification soon. Okay. So what I do is I would have to choose between two type of error. Okay, I have to introduce this. Okay, whenever you rely on data to do decision, okay, you will always see this two-way table. Okay, if our statement is true and you don't reject it, then this is right thing, right? If the statement is false, you reject it, do the right thing. Fair, okay? But if your statement is true, you reject it, that's called type 1 error. Okay. If your statement is false, but you fail to reject it, it's type 2 error. Is that clear? Okay. And unfortunately, there's nothing we can control type 2 error. Okay. And there's nothing we can do for this one. Okay. You cannot control it. The only thing that you can reduce this is have larger sample size. Type 1 error we can control. Okay. This is something usually we take 5%. Okay. 5% we allow this to be true. Okay. So let's see this example. Okay. So suppose that your data follow a normal distribution, the bell curve. Okay. Under the hypothesis, it should be the bell around this region, right? The T would look like this one, okay? It is unlikely that if this is true, it can't be true. Very likely that you would see this and here. right? If this is far away enough, right? If it's far away enough, you reject. Okay, let me repeat the statement here. Okay, let me draw a picture because I think it's too complicated. Okay, after this I have a break. Okay, X bar, you are a normal. Okay, oh, it should under the X now. There's A here, right? Because I said mu is A, right? This is it. Null hypothesis. It should be around here. Okay, and if it is too far away in the blue region, it's too far away, then I would not be happy with this initial thinking is mu is A, right? It's too far away. Okay. And of course, the question is how far is far away? The classical is what we call type 1 error. We will say if this is 95%, right? This probability, right? And this is 2.5%. Or 2.5%, right? It's 2.5%. Then this is far away, right? So if you convert this to t, right? I think you learned that in your undergrad as well, right? T n minus 1. This is 0, right? And these are the critical value, but I'm not going to write that. But again, this is 95% here. Okay, and this is what we call the critical region, or we call the rejection region, right? Is if your data calculated t is in this two extreme area, then you reject, right? Because if it's actually A, it is unlikely that in blue area. Of course, it's possible, common error, right? Even it's true, it's like it still has small possibility there, but we would think that small possibility is going to be against this thing, right? So for example, like this, okay? Suppose there's a murder happened to be some remote area, okay? In the middle of nowhere, okay? And the police find some guy is actually happened to be nearby that area, okay? And how likely he's going to charge that guy of murder, okay? If this guy, right, is home is next to the middle of nowhere, that's okay, I mean, he's not walking around, right? But his home is so far away from the crime scene that is too far away, then okay, we will say he can't be there for no reason. Although he's random walking, he's sleepwalking, he walk around, right? But it's so far away that he end up there is very low probability. Then we try to charge him, right? So that's the idea, right? Is assume this A, but it's possible that it's actually here anyway. But the probability is so low that we say only 5% are here. But yeah, we just say this is going not to support that mu is here. So that's the idea. I hope I convinced you that, but this is undergrad thing. So if you give it, I know that some of you have give back the statistics knowledge to your undergrad teacher, but don't worry, we are not relying on how to derive that. The idea is like, in general, it should be here, according to hypothesis. But you're too far off, then not the case, right? Okay, suppose it this way. Okay, again, a woman is waiting at home at the midnight. Okay, husband's not home. Okay, he go and find her husband. Okay, and he found her lying downstairs. Fine, maybe it's okay. Okay, but if he found he is 2 miles away in a KTV room, then probably her husband is not doing something great, right? Or her husband is actually somewhere in the pub, right? Far away, maybe 10 km away, then probably it's not, right? So that's the idea, right? You see the meaning, I hope. So I'm not going to talk type 2 error, okay? So besides the critical region, okay, and one thing that you have to know is the either p-value that are related. Okay, it's a very simple idea. Okay, and so the critical value are telling me that if the husband is in this region, then you will call him cheating. Okay, it's the forbidden area. Okay, KTV or the massage place or the haircut place, right? Then you shouldn't go, right? You go, you find there, then immediately disqualify, right? Now, relatedly, it's not about forbidden area. It's about p-value, means that if her husband is here, okay, can we say something more, right? It's not in the forbidden area. Okay, can we say something, okay? That's called p-value. The p-value will be, in our particular example, is this tail area times 2. Okay? This p-value is the area times 2. Is how dangerous is this area? Okay? If this thing is more than 5%, then it's okay. It's safe. If this is less than 5%, then guilty. Okay? Is that clear? The p-value. Okay? And whether you use critical value or p-value, the same, right? Critical value tells us which is a forbidden area, right? The p-value is more than or less than 5%. And you look at data output, they give you both. Okay? And we often use the p-value because p-value is convenient, right? 5% or less. Okay. Sorry for a little bit too long for the break. But let me finish one more one slide here. Okay. There's one slide, and then we'll break. So I have a simple one sample t-test. Okay. And I use the Science Python and from the stat library. Okay, I call it ST. So here I have a sample is 5, 6, 7, 8, 9. Okay, this data. You can make up any data you want. And the third line is the null value, means that mu is equal to what number? A is 7 here. Okay. And here is the good thing is I do the t-test directly. Okay. This ST, the stat, t-test one sample. You give the data, you feed the value, automatically give you the statistic and p-value. Okay, so that's why I don't care too much about the math, because you anyway plug in this, you're done, right? You don't care mechanics. And for the rest of the semester, basically just like I tell you this is a test, the Python give you the value, then you just make decision based on that. So that's why I just brush very quickly on the math, because we don't really need it, because not a math class, not a stat class, right? As long as you know how to do it, right? You can change the null. Maybe you make the null free. Okay, say null is free, then of course you reject, right? Because you say free is here, your data is here. I think it's far away to say that the guy has been to KTV, right? So that would be the idea, right? So let's try. If you don't, let's copy this and then break. Okay. So this is the case. We just we connect. I think we are doing the chapter, another chapter, right? Chapter, I don't know. So for this one, you can see the p-value is 1, right? Because my data is 5 to 9, and then you try to claim it's 7, so there's nothing violate from the data, right? But if you're thinking that, hey, if you know that the husband usually is at home around 3 to 2, right? Right, it's a normal place, but he go to this casino or haircut places, right? Then probably you find the p-value very bad, right? So in this case, p-value is 2%, right? So basically, less than 2%, 0.02%, right? So basically, this guy is disloyal. So you just divorce, Right? So that is the idea, right? So only thing you need to care is the p-value, right? The p-value 5%, 5% rule. Below 5%, then you reject. Above, you don't. So that's very simple thing you have to remember. And this example, I think you learned it in undergrad, but of course, as I said, I mean, many of you have give back to your old teacher. Try to reclaim back some of them, but don't worry. As I said, we don't really need the math. Just know the p-value idea, because all the output in the future give you all the p-value. Okay. So let's have a break of 15 minutes. Then we will consider more different texts and look at another example of the price data, and that will conclude this part. Okay. Don't worry, we're able to finish the rest of hopefully I can give you assignment. But don't worry, you can wait a little bit. So in the rare case where you want to ask a question, you can do it on the you reply. If you don't have a question, you don't have to fill in. Just in case you don't want to ask question in the class, usually you leave the question over there. But feel free to rest.我们不会只考希望大家都有一点小小的印象。这样的话，大家要学这个学习的问题啊。所以我们会教一点自己学习，我们准备教完，我们待会教完给回归以后考自己学习。人类人嘛，那个考的一般什么关系？一学期考一个按那个电就可以了，很简单的，一学期关系好。你待会看看哪里比较。把别人的扣改出来，对，改的参数，改对。要讲完了，对呀。我给大家再讲讲这个东西什么意义，有怎么跑，然后去跑出来的多。啊？差不多。之后他会比。你看上面，基本上应该要3门课一点。应该其他课都有点，应该我们的作业是比考试的多。我们可以翻上去年考试，觉得太严了。没有关系啊，你们不容易。用课啊，这个分数没有关系。所有人都考10分，100分考10分都打1个，没有影响，对不对？没有。你更难的没有关系。希望你们能学到东西最重要。你叫人那么多学费的话，没有学到的话，分数不了。大家的分数没有什么区别。现在比如说，不管考多少分都是考外码，给人下降。
但做 IT 的IT 不对，部分都是要不能加班。对，很多 ITM 啊，做 IT 的都是现在都加班的，就是说每次都是一个这个。因为我他们这样都没有所有老师都是年轻的，对，白头发。俩的，开玩笑，因为我不懂，大班很多都是。挺好，为什么呢？那就开始，因为我很久他们说，专门说几个办法，都是他们对对，所有中国人，但是也都不是中国人啊，一直到大了，对，在他们那边中国有点习体验的，习体验里面肯定还要讲中国人，就说你在家国家的嘛。做完就加了他，他都没有到。和老外的系统，具体都没有。我看以前我看有点小小的感想。好了，啊，我们干嘛写个写推门，水战到底。连我们说的这个时候，那个说是办公室开放啊，那个是学习嘛，都快打完了，到5点钟快打完了。因为我天天说着不打，我太厉害了，基本太厉害了，这很清楚说你什么时出这个牌。然后太难了，我打麻将都是想讲是吧？跟英文他休息了，大家都在想，我太累了。我是针对娱乐的，但是他们比较说很清楚，这个水就是他们的。我看出来的是。 应该考虑什么 idea 的马上打在。马上的话，4个人，3个人，2个人就5个人也不搞报告。我怎么搞？
一条换一批。不是经常下去。
所以你也聊完了。哦。你们在学什么？哦，你现在是打了一个这样的然后才。对，跟你们还有一点，我会跟大家说，因为应该对，你们应该有不可以做对。把打房价应该有麻将的数据来说。没有数据感，没有是拿什么现在马上拿下来，作为什么人可以拿一个头发穿什么衣服有这个
没有知道什么。为你们考试有点。
对，刷一个，刷一个，长一点。应对方，如果这个超酷了，对吗？会的话就是那个新手去站起去。
Okay, let's see if you have anything. You have 20 people reply, so let's see if a question. Oh, nothing. No, that's good. T-test, yes. Yeah, so far it's okay. Seems to be fine. None. Okay, that's good. Hopefully, by Friday or this weekend, I would try to release assignment 1 because I think we finished enough chapter that you can try to do something simple. So don't worry, just ask you some basic Python command that asks you to do something. So it shouldn't be difficult. Not theory, just some basic Python. I mean, basically just well, you learn there, you should be able to do it. Okay? But of course, in the worst case, ask AI I think can do most of the thing. But try not to ask. I suggest you try not to use the AI before you can't really figure it out, but you can use it because try to look at the slides and learn a little bit maybe better because basically everything is come with slides. I try to make the assignment not too long, right? So basically you expect to finish 1 hour or less or half an hour if you know detail. So if you need more than that, either you don't understand what I'm asking or you don't understand what the class is about. Okay? But shouldn't be too long. Okay. So I guess now before we do that, we are another test is called the 2-sample test. Okay. I think this is the most useful thing is often we have 2 samples. Okay. We want to see the 2 samples the same. For example, your ITM, right? Your IT manager, you have data of the website, you want to see whether man or female would be different, right? If they're different, then probably you have to design different scheme for them, right? So the first thing to do to check whether they have the same pattern, right? So suppose the data sample 1 is male and 2 is female, say for example, or sample 1 is from Shanghai, sample 2 is from Shenzhen. Do you want to have different program, right? Do you want to customize that, right? Because of the cookies, you know what people who come to your website, right? So what you do is you do the 2 t-test, okay? And you will use the independent one. The independent actually means that the man and the woman are not the same in terms of data generation, okay? I don't want to go to detail because the thing is you give back all your stats to your teacher. So I don't want to talk about related sample, those kind of things, but this is okay. Just use independent, okay? And if you want to know more, look at textbook, but I don't think you want to go, but this is okay. Just use independent because when the sample size is large, this is okay. Since you are doing the large data for IT manager anyway, so that will be okay, independent. You can check back if not independent what to do. But use independent, look at 2 samples and check they're different or not, okay? In that case, you figure out that, okay, p-value is 8%, okay? So it's not enough to say they're different, right? Then you can just combine, say, suppose this man and woman, just combine them. If they're enough different, then you may want different treatment. Is that clear what this is about, right? So this is the 2 things you want to do, right? One sample test, one other 2 sample tests. Okay, this is very commonly used technique, okay? Now, the question is we call the data set we call billion price project, which is going to look at all the price around, I think, 30-something country, online, offline price. And of course, IT manager, something you may care as well is you care about whether the price of online, offline are the same or different, right? It's very obvious question. And we can use 2 sample tests here, right? So what we want to do is look at the price difference between online and offline. Look at the difference, okay? Turn out to be a little bit counterintuitive. You may expect the online price is lower. Turn out to be, on average, not the case. It's actually 5 cents more, or almost, can say almost the same on average. SD is $10 for this sample of 6,000 observation. But of course, this sample turned out to be, not surprisingly, as a large range, right? Can be different by $300 and can be positive by 400, right? So this is data, okay? So probably you want to look at the histogram to give you a better idea. The histogram look like this, okay? Actually, turn out to be majority are close to 0. Maybe I have to move this away. Okay. How can I get this out? So majority are 0 here. Okay. And of course, there's something here, there's something there. Okay. So that would be the data we have. Okay. We'll draw the histogram, but okay. Oh, I forgot the word. I think seem to suggest that there are many extreme outliers. Okay, I forgot the. Okay. So what we're going to do is we will download this data from this website. I think this is no need to explain. We've done so many times. So what I do is just copy this one. Some of you ask why I do that. I don't know. There's some reason in the code that the encoding to make sure that it works, but I don't know why I have to do that. Probably it will work without that, but I don't want to bother. Maybe it's okay if we don't use that. Let's see. Yes. No, it didn't. So we complain. So let me do it. Okay. I think that's the reason is because the CSV file has some crazy character there for this to work. I'm sorry. I mean, we can't disbanded away because I think we do something must have some reason. So now what the data focus on is focus on USA, right? And want to look at the regular price data. And here is, I don't know why he do it, but he'll focus on first the sales online. There's no sales on online because they're discount, right? There's no discount. And it must be the case that the price and online is offline price. Online price, they are not NA, otherwise you cannot take a difference. Is that clear? Okay. Is that clear what he's doing? Data filtering. So they focus on USA country and focus on regular price and focus on the case where there's no sales online. So online means like December is a Thanksgiving, November Thanksgiving, or December Christmas in the US, right? It's not November 11. Oh no, Black Friday, right? And not those days. And the online price, offline price are there. Okay. And then here, another filter I impose is look at the price is less than $1,000 because look at regular objects. Okay. And this LOC just get those data there. Okay. So that is what we're doing. I hope this is clear. At this moment, I think after so many class of data filtering, you should be very comfortable with all this. Okay. Don't worry. As I said, with assignment, we will ask you to do something like this. Okay, construct this for me. Okay, basically, that's what we'll ask an assignment. Okay, download the data, clean the data, run some analysis. That's what I'm going to ask. Okay, so don't worry, shouldn't be difficult. So the next is, as we define this online price minus offline price is price difference, right? So there's a difference. And after that, we will use a function called describe. The describe will give you some basic statistics like the mean, max, SD, median, all right? Account is data. Let's run that. This will give us the data that is the EDA, right? Because this is, we want to do the data, right? Just download it, clean it up. And then once you clean up, you want to know what it looks like. Okay? So you take a difference, and this is the thing we care, right? This price difference. And I didn't explain, but if you look at this, if this thing look crazy, then you have to clean again, right? So that would be something like you should do, right? Because you clean until you think it's representative, okay? As I said, outlier, do you kick out the Monday until you clean until Monday is gone, right? Until that fit what you think is the right thing. There's no true or false answer to that, but you have to make your own judgment. Now, this gives you the count, mean, SD, mean, median, max, and lower quartile, upper quartile, right? So you can see actually the upper quartile is 0. And there's basically a lot of 0 here. Okay. And probably, as we said, once you did that, you want to plot the data, right? The histogram. Well, of course, you can do the box plot or whatever, but I look at the book, they all do histogram, so I just follow that. Okay? You can do a box plot or violin plot if you like, or the bar chart or whatever, but let's do a histogram. I hope we have so many times done. This is okay to be okay, right? I will probably ask this in the assignment as well. You're able to plot this kind of diagram, right? You know what to change here, but okay, this is something I would expect you to write, right? Is that okay? This is something that I will ask in assignment 1. Okay, and this is all the problem. Clean up the data, do the EDA, and then do the diagram. Okay. And as I said, right, because you can see some dot here, some dot here, there, but mainly it's the 0. Now, what do you want to do? Okay. we want to test the hypothesis whether there's no difference between the online price and offline price, right? And if there's no difference, then our life is very simple, right? When you compare prices across country, we can just go to online, right? We're going to go to offline because that's simple. There's no difference. So if you want to do any research, we can just look on the price and our job is over. We don't have to go offline, right? So that is a conclusion you can draw if that's true, okay? So what we do, this is a standard technique, right? The SE, follow the standard procedure will be like this, okay? Of course, this SE is based on mathematical formula. Remember, we can do bootstrap, same thing. We can do resampling, can also give us SE, right? We will create data, two data set, do a difference that generate many difference in one universe. We create 1,000 universe, that gives you SE as well, right? Of course, that will be more complicated because you generate not one sample, we generate two samples, right? And do the thing, right? But in theory, you can do it, right? You can create that data set, okay? But we use the theory, sample standard deviation divided by root n will be the SE, okay? But that's, you need not use this one, but there's a standard, okay? And this over SE would be 5, okay? And because the data usually more than 200, right? When data is more than 200, the critical value is 2, plus or minus 2, right? So I should have mentioned, here is, something I forgot is this critical value for our purpose is always 2, right? Only if your data is less than 30, which never happened in your IT case, right? Your data is more than thousands or even 10,000. So 2 is the critical value, right? So for us, 2 is the KTV area, okay? Now, what we have is this set is not more than or less than plus 2 minus 2. So we can't say they're different. So we're done. We conclude that the online price, offline price are no difference. Okay. So of course, the first thing to do is you can look at the first principle. All right. Is what we do is calculate the SD, right? The standard deviation for that. Okay. And calculate the small n, right? And calculate SC by taking SD over the root n, right? This is raised to the power. Double star is take the square root, right? Double star to the 0.5, taking the square root, right? And then you take the sample mean over this SC, then you can come up with the SC then the same thing. Is that okay? So we got the all right, the T stat is no more than 2, then you just say bye-bye, okay? And of course, you can simply apply this even faster. Is t-test, one sample, put a diff and 0, then you're done. Right? So fast. One step. Can't be faster than anything, right? Just light speed. Doop. Right? So p-value is so big you can't reach it. Right? So it's, I guess it's fast, it's quick enough, right? That's very simple. That's done. We're done with this one. Okay. So of course, we will keep doing this kind of stuff when we do regression or modeling, but I hope that these things that I can, you can look at it and then see how you can apply. As I said, the assignment, I try to have time to write it, I'll do it and then try to release it in the weekend. Then we ask you doing some Python coding. So don't worry, because as I said, I don't really want to ask statistics knowledge. So, and the quiz already asked the basic thing there. So I want the assignment, at least for the first assignment, I want you to have knowledge of running some Python code. Okay. And the Python code I asked you to do is actually the thing we run in the class. So shouldn't be if you understand what's going on, then shouldn't be an issue. Is that okay? So, although we went faster, but I think we should at least give you some idea what we learn in the next class very quickly. Although, I mean, you will give me back after this class, but just very brief review. I don't want to bother you anymore because I think you're overburdened. Some people are very sleeping, but I try to tell you what we're going to do next week. Okay. Next week is basically do regression. We try to come to a real model. Okay, this is the real class. Okay, before we're just having fun. Now we're going to come in serious because we estimate model and use the model to do things. Because this is the key part, right? Because so far we're just having fun with something toy thing we learn undergrad. From now on, become more applied. Things become serious, right? Because the idea is actually we're doing is this guy. If you recall, this is the key we're doing. Okay, we're trying to fit this thing for the next class. We're trying to tell you that when you give the data y and x, we're going to build a model to explain or predict y. Right? Those of you who said y is horse racing outcome, x is bunch of characteristics, right? It's whether x is who is the horse father, who is horse mother, who is the grandfather, grandmother, right? Who trained the horse, what kind of food does the horse eat, and so on and so forth, right? So on and so forth, right? So this is the idea there, right? So that is trying to explain the performance, right? And these are the key thing, right? Because we want to use data, have a model to tell us what's going on in other scenario, right? Because do know that this is not trivial. We want to try to draw a line is a big jump from the point, right? Because the point only tell you that this x with this y, right? We only have finite number of them, 有限的数据. But when we look at the line, it's infinite number of points, 无限, right? Just unlimited, just so many things, right? Just basically just the conclusion we jump is a lot, right? But of course, we can simplify the world into several numbers. In here is parameter alpha and beta. But of course, we will jump ahead because grad class, we just immediately jump to beta 1, x1, beta 2, x2, say beta 3, x3, and so on and so forth, right? The many possible factors can explain why, right? We're going to do what we call regression to find the best fit line to that, okay? After we estimate these betas, we have to go to hypothesis testing to see whether this beta is 0 or not, okay? And once we say this model is right, then we'll do some estimation, right? Because these are the best point, right? But we still want to have a confidence interval, telling that if x, the best guess is this guy, right? But it's not done yet. We'll tell them, okay, this is the range plus minus 2 SE will be a guess. This is how we use the model. Not the line is not the end of the story. There's so much thing behind the line there, right? How good is the line? It's R squared, those kind of things, right? And then what is the format of this regression, right? Maybe do we allow nonlinear terms? Say beta 4 is x1 squared, nonlinear, right? Or take the log form. That many transformation can be done to better fit the data, right? So, but that will be the talking point for the next week, okay? But basically, this is the goal, right? It's the regression. And just to give you a more highlight for the rest of the semester, because I think it's the right time to tell you what are we doing for the rest, because I think you have so many classes, you easily get lost somewhere, right? And unfortunately, lesson 5, we continue to do what I said, confidence level. This is what I just said. This is what the topic 5 is about, all right? Lesson 5. And then lesson 6, what we learn about is probably lesson 6. Sorry. Lesson 6, unfortunately, I think we have to, if you don't have time, we completely skip this class because of the time reason. Okay, at least we will maybe skip the chapter 12, but I don't know how much time we have. But if we skip this, we will jump immediately to machine learning and prediction, because you are learning as a human, so you want to learn how machine learn, right? This is the part we will learn. The linear regression is probably the first model jump from regression to machine learning. Okay, and the reason that what linear regression later we learn is when you have your IT manager, right? Then you have a lot of columns in the data, right? Maybe you have Y, oh, where is the one? The Y, X1, blah, 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 X2, blah, blah, X1000. Okay, many columns, right? You run the regression, a huge object, right? But most of them are useless, you can say, because they be very similar. So is there any way to automatically select which variable to use for prediction? That's LISO is about. Quickly run a regression, and then there's some way, which we will learn later, to cut out what's not there. So it's still regression, right? Machine is learning how to select which one. That's a way to do it. But don't worry, machine will do it. You just type LISO, tag, then come out. Okay, don't worry about that. So you don't have to worry about that part. We're not going to do the math behind, but there's a button, you click, then something magical happen. Okay, don't worry about that. So, but I will try to teach you what is the magic behind and how the magic works, but we don't tell you all the mechanics, because that will be that other class, right? I don't want to repeat what other class we do, but just tell you something that may be there. Okay, and lesson 8 will be what we call regression tree and random forest. Okay, the main idea here is I want to draw a line regression, right? But things become linear. Okay, and is there any way around non-linear stuff? Okay, there's some cutoff, and you run different regression by cutting some area. Say maybe you put it this way: when x1 is below 10, you have this regression. When x is above 10, other regression. Okay, that will be the regression tree, and some forest over there. But I'm not going to go. I will go to detail later. But this is the idea. So basically, you can see regression everywhere, right? So once you know the regression, the rest will be clear. And I think up to here we should have time. Okay, and this up to here is AI prediction, and the lesson 9 and 10 is to establish causality. I don't know I have time, but I'll cover some of the topic. And in particular, I think we will cover at least the 9 and 10. We'll select at least one or two chapters. At least we'll tell you how to do the diff and diff and panel data. Okay, this is a method you try to uncover your causal relationship, because you observe same individual over time. Okay, then you can try to avoid the problem of you observe this because of individual characteristic. Okay, and as IT manager, you always have panel data. Okay, you can always have difference. Okay, and different I will talk about later, but it's like related control group idea in experiment, right? If you want to say the drug, okay, there's a drug, and apply to this handsome gentleman and this beautiful lady, right? Then say drug work for him, not work for her, cannot tell anything, right? Because maybe the drug only work for men, right? What I'm going to do is I will find a guy, also a very handsome guy, same as him, give him a drug, and give another guy a placebo, a fake drug. If that works, then actually the drug will work. So the problem of difference is trying to find a comparable group and look at the difference, right? Comparable, same, similar, handsome guy, and then no comparison, right? Then that will work. But that will be the rest of the class, right? We have covered all the foundations. The rest will be regression, machine learning, and different is also regression. So basically regression for the rest of the class. So I hope you'll be happy, but I'll give you assignment. So at the end, so happy, do that. I will see you next week.